Today we've got none other than Mark Weber joining us. And one thing to note about this, we've got Mark and then Misha is going to jump in for the question and answer section. Misha is the scientist and Mark is the applied researcher. And they did this work for Wells Fargo. And so that everyone knows, Mark is actually at MIT, IBM Watson AI Lab Strategy Operations Lead at IBM. And without further ado, I think I've talked enough and it is ready to be taken over by the man himself, Mark Weber. I'm excited to hear what you have to say. Please let us know. Enlighten us, Mark.
Okay, thank you, Demetrius. It's a pleasure to be here. I see we have a nice group of people here joining us. So I'll give a presentation for about 20 minutes, but then we really want to open it up for discussion. Great, as Demetrius said, grateful to represent the MIT IBM Watson AI Lab with you about this important topic of fairness in lending. We're going to share a paper that we published in the NeurIPS Fair AI in Finance conference just a few months ago. And the title is Black Loans Matter, Distributionally Robust Fairness for Fighting Subgroup Discrimination. We basically start with, our starting point is that similar individuals should be treated similarly, irrespective of the color of their skin. And the problem is that our current methods for enforcing fairness in lending don't actually guarantee this. And we argue that the reason for that has something to do with subgroup complexity. And there are methods from individual fairness versus group fairness that we can take to address this problem. So lending is a historically controversial subject because it's a double-edged sword. On one hand, access to affordable credit is an important tool for financial freedom and prosperity, and for extending equal opportunity to minority households and minority-owned businesses. The Consumer Financial Protection Bureau estimates that 20% of people in the United States today are underserved by credit. And I will say, by the way, I know this is the Toronto Machine Learning Summit. This is a US-centric presentation, but I imagine there may be aspects in Canada that are relevant to you. So I will say, though, speaking as an American today, these are kind of US-centric figures that I'm going to be sharing with you to motivate this problem. So our Consumer Financial Protection Bureau estimates that 20% of the US adult population is underserved by credit, and this population is much more likely to come from minority groups. And then the other hand, lending can be an aggressive and predatory practice that lures people in and traps them in cycles of debt. And the policies and practices leading up to the 2008 financial crisis illustrate this tension between lending as harmful versus lending as helpful. And one of the core mandates of the Consumer Financial Protection Bureau that came out of the 2008 crisis is to help us achieve the right balance there. In the United States, we have checkered racial history of discrimination in lending. This map that you're looking at here is from 1936, and it's a residential security map of Philadelphia, classifying different neighborhoods as having different risk levels relative to mortgage lending. And in the 1960s, a sociologist named Joe McKnight coined this practice redlining, because we found that really these mortgage risk neighborhoods fell almost exactly upon racial lines and racial neighborhoods around the United States. In the 1970s, the United States issued two acts, the Fair Credit Reporting Act and the Equal Credit Opportunity Act, to try to fight various forms of discrimination among protected classes, including race and gender, and other protected classes. But by the 1980s, Pulitzer Prize-winning author Bill Dedman published a series of articles showing that massive disparities in lending still existed. And he started at these Atlanta neighborhoods, and then he expanded his essays all over the country, demonstrating that that despite being encoded into law, there was still massive disparities in outcomes for people of color in the United States. If we fast forward to today, just very recently, a 2019 landmark study called Consumer Lending Discrimination in the FinTech Era looked at 13.2 million mortgage and refinance applications. And they found that Black and Latin applicants suffered 61% rejection rates versus 48% for everyone else. And that even in FinTech lending, this is like more algorithmic style lending, they were suffering a racial premium of 5.3 basis points on mortgage interest rates and 7.9 basis points on overall mortgage interest rates. This comes out to $756 million in an annual race premium that Black and Latin applicants are paying in the modern day. You know, this is no longer the 1950s, 60s, 70s, 80s. This is the 2019. This is the disparity that we're finding today. So it's a very real and pressing problem, and it's noteworthy that we already have the laws in place that are trying to protect people. So there's something deeper going on in the methods we use to enforce those laws and to uphold fairness that is breaking down. And you know, the good news out of this study is that there is some reduction in the racial premium on interest rates, and the rejection rate parity actually was fixed in this study by algorithmic lending versus more of the traditional face-to-face lending. And so this leads us to believe in, to form a hypothesis that indeed biased algorithms are easier to fix than biased people. And there are things we can do at an algorithmic and mathematical level to try to weed out the implicit biases that continue to perpetuate into our system in lending. Now, actually, I want to motivate this for a second, because there's this, it's one thing to say we have to fix something. It's another thing to raise a level of urgency. I think there's a strong argument to be made for a high level of urgency on this problem, because every day that goes by that we use unfair or suboptimally fair algorithms in lending is another day that we generate new training data where we propagate these persistent biases into our systems. And so the longer it goes on, the harder it is to untract. And that should be a key for us, for any of those of you working in the banking or lending today, or working in policy circles. I encourage you to have a sense of urgency about addressing this, because the longer we wait, the harder it will be to fix. So the way fairness lending works today, and this is going to be a very simplistic, high-level overview, but there are three key areas that we can highlight. One is separation. Model developers are excluded from the fairness process to make sure they can't game the system. Another is blindness. So ironically, for better or worse, a bank is blind to race except for by racial proxies, which in the United States are actually provided by the government. And there's a proxy called Bayesian improved surname geocoding, which sounds kind of strange that we provide these. We blind to race, and then we provide sophisticated ways of proxying for race. And then lastly is group fairness. A bank tries to enforce conditional parity for known minority groups relative to the majority. And today, there are problems and pitfalls in all of these. Today, we're just going to focus on the topic of group fairness. Group fairness is, at a high level, is based on some conditional target variable that's appropriate, like income. We want to ensure parity among groups that, based on some inappropriate variable like gender, which it would be inappropriate to define creditworthiness based on gender, and various aspects of statistical or conditional parity include demographic parity, equal odds, equal opportunity, and prediction rate parity. Now, if these were high, medium, and low income people, we would want to see relative parity across men and women, very simply put. Now let's consider what this controversy in 2019, where the co-founder of Ruby on Rails tweeted, "The Apple Card is such an effing sexist program. My wife and I filed joint tax returns, live in a community property state, and have been married for a long time. Yet Apple's black box algorithm thinks I deserve 20 times the credit limit she does. No appeals work. This tweet, as you can see below, started a Twitter firestorm and actually caused a government investigation from the New York State Department of Financial Services. It did a whole bunch of damage to Goldman Sachs, what they had of a brand, certainly Apple's brand, and caused a lot of people to distrust the fairness of modern day algorithmic lending decisions. And it's an interesting case study for us to consider. We can only speculate about what happened. But at the time we wrote our paper, here was our hypothesis of what happened. It's a husband and wife situation, which he mentions in the original tweet. The Apple Card isn't looking at gender, so it's blind to gender. But if we think about a situation where we have a credit limit conditional upon personal income, and we have high, medium, and low, there might be a situation where Jamie on personal income is very low and David is very high, but they're married. So they might form a reasonable expectation of being treated similarly because they, as he says in the tweet, they live in a community property state. They have similar, shared everything. And yet, because she is in this subgroup homemakers, she is treated very differently than David. And sure enough, the timing of this is really interesting. But this morning, the New York State Department of Financial Services released their report and found that, and I'll actually read this because it's really interesting. While we found no fair lending violations, our inquiry stands as a reminder of disparities in access to credit that continue nearly 50 years after the passage of the Equal Credit Opportunity Act. The use of credit scoring in its current form and laws and regulations barring discrimination in lending are in need of strengthening and modernization to improve access to credit. A person who relies on a spouse's access to credit and only accesses those accounts as an authorized users may incorrectly believe that they have the same credit profile as the spouse. This is one part of a broader discussion we may have about equal credit access. And so in this report, what they're basically saying is that, yes, by the letter of the law, nothing wrong was done. But by the reasonable expectation of citizens with regard to what defines creditworthiness, indeed there feels like discrimination going on, where homemakers who in the United States are more likely to be women are unfairly discriminated in this case. And we see this kind of thing play out in various situations. If we return to the topic of race, and we consider two individuals, Tyree and Ryan, and these are names pulled from a data set of common African American and Caucasian names. We can say that Tyree and Ryan, let's assume that Tyree and Ryan are similar in every way, except for race. And if we have a credit scoring, a fictional profit maximizing algorithm that satisfies group fairness, we can run an algorithm and see that there's a scenario in which Tyree is rejected and Ryan is accepted, even though, as we've established, they're very, very similar. You could say the distance between them on a fair metric is very, very small. And what we can find is that there's this subgroup of middle income applicants. And the algorithm has decided, though, that for Black applicants, it's more profitable to eliminate all the middle income applicants, but for white applicants, it's different. And there's actually profit maximizing reasons for this. When you're trying to satisfy group fairness methods that doesn't account for subgroup complexity. So here, let's try this again. And here we're assigning upper interest rates to these different groups. And we can see that in this fictional profit maximizing algorithm, the high income applicants are being given, different interest rates, Black versus white, middle income the same, and low income, there's actually a racial premium, which, as we've established, we know exists on low income applicants for Black versus white applicants. And in this scenario, the algorithm actually still achieves parity both on interest rate and on acceptance rate from a group fairness perspective, and yet clearly discriminates against low-income applicants, and importantly, doesn't treat Tyree and Ryan similarly, irrespective of their race, given that they are similar applicants. And so this is an interesting thought experiment to understand at a very high level that this problem of subgroup complexity actually can cause our group fairness algorithms to break or have blatantly unfair outcomes, even though technically the fairness algorithm is saying everything is okay. So what can we do about it? Individual fairness is a class of methods that emerges as a potential solution to deal with subgroup complexity that can't be properly anticipated. If we could anticipate all possible subgroups, then we could just enforce group fairness subgroups. But the reality is practically we can't. And so I'm going to fly through some of the technical details here. But in short, this 2011 paper from Cynthia Dwork and her colleagues introduced this concept of individual fairness, where we can let a machine learning model be a map H, where X and Y are the input and output spaces. And assuming some distance metric, we can enforce a Lipschitz condition such that the distributions of outcomes are indistinguishable up to their distance. So if Tyree is X1 and Ryan is X2, if the distance between them is very small, they should be treated similarly. But practically, there are two challenges here. One, there's no generalization guarantees due to the requirement that this inequality here on the left holds for all possible pairs. And two, defining a fair metric is non-trivial. And so in Misha's work with his colleagues publishing in ICLR last year, they addressed both of these things in multiple papers. One here is this concept of distributionally robust fairness, where again we have this machine learning model map, and here we're going to say that a model an outcome is distributionally robustly fair if it satisfies this condition. And here the key, if you don't want to read all the math, the key here is that the distributionally robust fairness approach considers average violations to individual fairness to enable generalization of guarantees. And this is arguably the first practical approach to individual fairness versus purely a theoretical one. And as such, it can be used in a setting like lending. So to enforce distributionally robust fairness, we have an algorithm called censor. And with censor, what we want to do is observe all the data, generate all possible similar individuals to see if any different outcomes exist measured by the loss function. So here, if we have Ryan, we actually want to create a counterfactual for Ryan based on sensitive attributes. So like if Ryan were Black, would he receive the outcome? Yes or no? And the size of these X's and check marks is meant to describe the size of the violation and the proximity to Ryan relative to the fair metric. What we want to do then is generate all these possible pairs, update the parameters to account for the single worst violation, and then repeat the process until the violations are minimized. And what this does is it makes sure that in a scenario where Tyree is rejected and Ryan is accepted, while, as we've discussed, group fairness may still be satisfied, distributionally robust fairness is going to raise an alarm. And that's very important because we don't want things, blatantly unfair outcomes, passing muster when indeed they are actually unfair and they need to be flagged for review. So an example of this from an actual experiment. So far, we've been showing you kind of the theoretical framing and thought experiments. An actual experiment that demonstrates this this distributionally robust fairness approach involves baby names. So we can train an NLP sentiment analysis model using pre-trained word embeddings for positive and negative words. Unfortunately, when we feed a list of common African American and Caucasian names, we actually see negative sentiments associated with African American names versus Caucasian names. This is yet another empirical example of the implicit racial biases that exist in our society today. Now, the baseline here, if we're looking at sentiment, is is such that African American names are seen as more negative, Caucasian names are seen as more positive. There's also the whiskers show you the range. And group fairness, what it does is it pulls the averages of the groups together. And yet we still have scenarios where somebody like Tyree and Ryan could be treated extremely differently. And that's the problem we're trying to solve here is that we don't want Tyree and Ryan to be treated differently based on the color of their skin. What Censor does by enforcing distributionally robust fairness is it pulls these together and minimizes that range to make sure that there isn't at an individual level these gross violations of fairness. And importantly, it's able to do so in a way that accuracy is not compromised. And the fact that accuracy is not compromised is indicative of the fact that race is not actually a causal factor should not be a causal factor in the sentiment of a name or creditworthiness or these factors. They're correlations based on implicit biases embedded in the data. And so if we look at a second experiment where in this case, to close us out for today, a second experiment involves predicting individuals' income based on census data. And here we're kind of going back to the spousal topic. So SCON on the right is spousal consistency. And we want to evaluate Censor to enforce distributionally robust fairness against the baseline, which is adversarial debiasing, which is a group fairness metric. And interestingly, if we just look at this one result, there are a number of results we could look at, but if we just look at this one, we can see that spousal consistency measures the counterfactual sensitivity to relationship status, which is an unfair way of predicting, which is not something that would be admissible in a lending decision, for example. And Censor plus Explore, which is a way of deriving a fair metric, is best for spousal consistency. The group fairness metric, interestingly, the one adversarial debiasing, is actually worse than the baseline. It performs worse than the baseline method of enforcing fairness. So what these two experiments show in a small setting, and this is the reason they were published in some of the top AI conferences last year, is that the pitfalls of group fairness are such that we can end up with blatantly unfair outcomes, and that an individual fairness approach can help us address this. And in the case of lending, part of what we're trying to address is subgroup complexity and how that results in racial discrimination, persistent racial discrimination that continues to pollute our data. So in summary, we've established that racial discrimination in lending persists today. We do not live in a post-racial society in the United States, and I doubt Canada does either. Today's fairness algorithms are not actually very fair, and we need new methods to address this and resolve it. One method that we've shared with you today is called distributionally robust fairness, and an algorithm for enforcing it is called Censor. We really want to encourage bankers to update your compliance protocols. We know it's hard because regulation is such that it doesn't always encourage innovation and experimentation, but we want to encourage you to find ways to push the envelope and lead for society and for the industry. And we want to encourage policymakers to create an environment where bankers are encouraged to address these problems and aren't fearful of addressing these problems. We need policy and industry to work together with the support of the research community to address this and hopefully move toward a more fair society in finance and beyond. So that is our presentation, and we would love to open up for questions and discussion.
All right. First of all, awesome presentation. I was really interested. I've got some questions of my own that I'll throw at you, but there are a few hot ones coming through here in the chat, and I'll ask those first. If race is not a variable in the data, can an ML model, supervised ML model, for lending still discriminate? I'm going to take a stab at this one and say yes, but I'll hear the expert opinions.
Yeah, the simple answer is that machine learning models are incredibly good at identifying proxies. So, and proxies can, and it's also the case that, so proxy, a very simple proxy that we actually mentioned is zip code. You know, if zip codes tend to be correlated fairly strongly with race, and this is one of a number of different potential variables that can end up falling on racial lines. So in lending, there are more than one element of fairness enforcement. One is disparate treatment, but another is disparate outcomes. So even if you can say, we're not treating people differently, if there is a massive disparity in outcome across a protected class or attribute, then it is deemed to be unfair.
Excellent. All right, next one up. Can you talk about what happens in the real world situations when race is a predictive factor, but only because it proxies from some hidden variables we aren't measuring? Can SNSR, I'm trying to, do you know what that stands for?
Sir, he's referring, yeah,
right,
he's referring
cool.
to
work in that case if we aren't.
Where race is a predictive factor, but only because it proxies for some hidden variables we aren't measuring. So I think, if I understand your question correctly, I think that's what we're talking about here. So race is not, race is never allowed to be used as a variable in a model. But we, as we just mentioned, we do end up having proxies for it, including explicit proxies like the Bayesian surname geocoding one provided by the Consumer Financial Protection Bureau. So I think the answer, and Misha, you can chime in here if you want, but I think the answer to your question is actually what we just presented, is that sensor helps address this when we don't, even if we don't know those variables, because it can account for subgroup complexity. Now that said, it is much easier, and the range of fairness methods that are available to us is actually broader if we do have race as a variable, because then we can test for that. Misha, do you want to comment on that?
Yeah, so let's do such a thought experiment. So there are sort of two sides of the problem. So first, let's consider a problem of identifying who is a scientist, and we use some historical data for that. And historically, there were less female scientists. So the gender, or some proxies for gender, like a gender pronouns in the person's like CV or bio description, they could seem to be useful, and machine learning algorithm can decide to use them if it's not sort of stopped from that, to use gender pronouns to identify who is a scientist. And on that specific historical data, it might help to improve the accuracy. However, if you use sensor and we try to enforce invariance with respect to gender, so basically the FAIR metric says that anybody who differs in the gender pronouns are comparable. So we can enforce that, and the algorithm will not use it, but its accuracy may be reduced. So we've seen it in some of the experiments. However, it's not necessary that enforcing fairness reduces the accuracy, because imagine now that the test data for this algorithm is a more modern data where the prevalence of female scientists is higher. in which case actually the accuracy can also be improved because the algorithm learned not to use gender and mistakenly kind of discard females as scientists. So you can see how like maybe like essentially it's a bias in the trained data. So if in the trained data, race or gender appear as predictive of the target variables, and on the test data it may not be so.
Misha, thank you. So how does distributionally robust fairness work across other diversity, equity, and inclusion conditions?
It's certainly very broad. So when you define a fair metric, you want and you want to define like what does distance mean in the fairness setting that you're operating on relative to what is similarity, right? Once you define when you define what similarity is relative to the use case. So here we're talking about lending. So we're defining similarity as creditworthiness, which can be a composite of any number of appropriate variables to use versus ones that are inappropriate to use, like race and gender. Once you have kind of those conditions, distributionally robust fairness is a flexible and generalizable framework that can certainly work across other types of conditions.
Now, what steps can you take in evaluating predicting data aspects which are sort of linked to race?
Oh, and I also see this one real quick, so we don't miss it. How widespread is racial bias in non-mortgage products? It's a great question. It's harder to know, at least in the United States. We mentioned blindness. There are some exceptions to blindness in mortgages specifically versus non-mortgage products. So part of the reason that study was able to find the disparity that they did is because there are people can volunteer their race information on mortgages, whereas in other settings that's not a variable that's optionally included. And so it's difficult actually to figure out how non-mortgage products break down. But I would say that the credit scoring mechanisms in the United States for mortgages and non-mortgages is actually very similar. So if we see disparity in non-mortgages, it's a fairly safe assumption that similar disparities exist in mortgages because the scoring systems are almost exactly the same. Okay, what steps can you take in evaluating predicting data aspects predicting data aspects which are sort of linked to race? Clario, maybe you could rephrase the question. I'm not sure I understand. Misha?
I think I have a guess what Clario could be asking. So when we talk about fair metric as two individuals being similar, if they like only differ in race, I mean, we are simplifying the sort of the mathematical picture a bit, because indeed the fair metric is more complex than that. So it takes into account all dimensions, and we use some techniques to learn it from the data. For example, if you have a set of similar individuals, which is, I mean, usually when we have real data, there are no like exact kind of copies of an individual which only differ in race. So usually they also differ in some other variables. And from such kind of data of which individuals are similar, we can learn the fair metric, which is, I mean, going a bit technical here, is a form of a Mikhail distance. So it's x minus x prime times sigma times x minus x prime transpose. So we learn that sigma, and that sigma essentially takes into account all aspects of the data, not just the race. Indeed, race itself may not be even a variable oftentimes because we don't want to use it. So
awesome.
Yeah.
Awesome. So last one that I'm seeing coming through, and then I'll ask mine. What about precision and recall?
That's I mean, the precision and recall are just parts of accuracy, basically. So we didn't specifically measure some of the experiments, but they could be, like, I guess it just requires like checking them out and seeing. But
yeah, I think it's those are interesting metrics to look at when we have asymmetries. You know, this potential, like there's potential policy implications of asymmetries between false positives and false negatives in certain settings, especially in finance. Like we see this like very big in anti-money laundering, for example. Like precision and recall are very important metrics because it's not about total accuracy. It really is about making sure that no bad guys get through the system. In a similar way, in fairness, if you think about precision and recall in the context of subgroups, maybe there's, relative to a whole population, there's a small subgroup that's being discriminated against. But if the subgroup is sufficiently large to cause a stir on Twitter or to band together and file class discrimination, then it can be a problem for the bank. And so I think this actually kind of speaks a little bit, in my opinion, to the Goldman Sachs example, where at a total accuracy level, they didn't have any concerns, but there was like this sufficiently small subgroup of people who were being classified in such a way that exposed them to the controversy and made them vulnerable, even though, again, technically by the letter of the law, they didn't do anything wrong.
All right, so last one, and then we will call it a day. I'm wondering, you talked about how the urgency is very necessary here. And with each day that passes, we're just like propagating this bad data, right? And so do you feel like there's brakes put on all of these different algorithms that are out there before we get it right?
Well, it's important to remember that the traditional lending practices actually today are, like the 2019 study shows that the traditional lending practices are more unfair than the algorithms. So it's not that algorithmic lending is necessarily driving more unfair outcomes. It's that algorithmic lending to date has not fixed this intractable bias that still exists. And so rather than resting on our laurels and saying, hey, we live in a post-racial society, we have these laws, we have, algorithms that don't factor race into the model. We have to acknowledge that there's still more work to be done.
Excellent.
I think to add to that, I actually think we shouldn't sort of put a brakes in that sense that the businesses that are concerned with the fairness of their products, they should follow the literature and they should have a habit of implementing the new methods and updating them, because the new methods, they don't make anything worse. I mean, they make things better, but as people on the other side, so the researchers, we of course want to do even better. So there is some ideal that we try to achieve. We may never be able to achieve it, but for that, to make sure that the research got into business, there should be the businesses should also develop a habit of knowing what's new and having a quick way of kind of deploying it and testing it out.
Excellent. Well, thank you both for this enlightening session. I really appreciate it. I see that there's some people sharing that they really liked it too. And we will see you in the next session, everyone. Don't forget to fill out your profiles. All right. Thanks again, Mark and Misha. See y'all later.
Thank you, everyone.
Bye.